profit and loss. Then we'll be ending the lessons with profit and loss percentage and then simple interest as well as high purchase. It's my wish that today we'll be able to take the first 4 objectives, that is definition, percentages as common fractions, fractions and decimals as percentages, then ordering a combination of fractions, decimals, and then percentages. This is what my target is for today. If we have more time, then we'll be looking at relative error and then percentage error. Please, are we all settled for the lesson to begin?
Yeah.
Those of us who are not seeing the screen, please, can you see the screen now?
Yes.
All right. Then let's start. Yes, any question before I start, please? Any question before I begin? I'll be very glad if someone starts recording the lesson. Okay, so let's box on. So to begin with, percentages is a topic you've actually had a fair idea of. You've been hearing of it and you've been using these words often, more often. So if I may ask, in your own small way, what will you say percentages are? Yes, in your own small way, what will you say percentages are? Or what is it? Yes, Emanuela Thompson, can you tell me something about percentages? Yes. Any other person?
Sir.
Yes, I'm listening.
Okay, percentage can be a number that can be expressed as a fraction of 100.
Okay, I like the definition. So Emanuela is saying it's a number expressed as a fraction of 100. I really love that. Yes, any other person to add up?
Yes. Percentage is a number out of 100.
So you also equally say that it's a number out of 100, a number out of 100. Okay, I'll just base on these two definitions and then we'll continue from there. But the next question I have for you is that why is it necessary to study percentages? Why is it necessary to study percentages? I hope no one will tell me that it's for WASI reasons, please. Yes. So why is it necessary for you to study percentages?
Since I think in one way, it can help us reduce like a bigger quantity or a bigger number to a smaller size.
Okay.
That is worth testing.
Can you take it again?
Yes. When you take a percentage of a number,
Yes.
let's say the number is like 10,000 or a bigger number, it helps you to like reduce the size of the number, but you still maintain the worth.
Okay, that's good. Can you cite an example?
An example is, okay, 50% of 100,000.
Okay,
When you say 50% of 100, when you solve it, the answer will be 50,000. But instead
50,000.
of saying 50,000, I say 50%.
Okay, okay. That's very good. Any other person to add up why the need for us to study percentages? Remember, it's a discussion. When you are able to bring your contribution to the lesson, it makes it easier for you to understand and work things out. So please don't be an Egyptian mummy and sit on the fence and then listen to others, but also bring you on board what you have in mind. Why is it necessary to study percentages? I just need one more so that I'll bring on board my ideas as well. Okay. So,
Sir,
yes, I'm listening.
sir, please, I think to enable us to have one more way of writing numbers.
Another way of writing numbers. Okay, that's also good. That's also good. Thank you so much for your contributions. Now, to begin with, as you rightly said, percentages is just a number expressed as a fraction out of 100. That's a perfect definition. Or you can say that it's another way of writing fractions, but this time around, the denominator must always be 100. Or you can also equally say that percentage is dividing a quantity into 100 parts and taking just a fraction of it. Percentage is dividing a quantity into 100 parts and taking a fraction of it. I've given you two definitions. It's a fraction written out of 100, or dividing a quantity into 100 parts and taking part of it. That is simply what percentages is, or percentage is. Now, why is it necessary for us to study percentages? You realize that I like one contribution that came on board, that you can use percentage to express larger quantities into smaller values, and that is so perfect. And I'm going to, based on that, give you some definitions or give you some examples for you to be clearer on it. You realize that, let's say, in the year of elections, many people go to the poll and then they cast their votes. The votes are so high and the numbers are so large to the extent that sometimes the layman may not understand the numbers. It makes it so difficult for them to relate the numbers. They may think that, oh, this person has lost or this person has won, and so on and so forth. So to make it easy, when all the votes cast are actually investigated, they give their final verdicts in terms of percentages. It makes it easier for the layman to know that, oh, this person has won the race in terms of percentages. So it's simply helping us to express larger numbers in smaller quantities. That is all. That is one major reason why percentages are very important to study. Then again, you can base on percentages to increase a quantity or to decrease a quantity. Going further, you can still use the idea of percentages to manipulate figures. When I talk about manipulation of figures, this is what I mean. When there's an error occurred in some calculation, you can use the idea of percentages to correct them. And these are some of the things we'll be learning in this topic. Now, when it comes to the business sector, we have discount and commission. We have simple interest. We have compound interest. We have high purchase. These are some of the things we'll be talking about when it comes to applications of percentages. So, for your information, the study we are going to have, it is not for WASI. It is purely for life. Because I believe one day, apart from you working in the government sector or in the private sector, you may like to have your personal business to embark on. And you should understand the concept of percentages to deal with. You realize that recently when the fuel prices went high, they increased what we call the fair prices. And they did that by percentages. I believe what I'm saying is right.
Yes.
So, my dear students, I want you to be very careful with this topic, percentages, and don't think that it is for WASI. It is purely for life. So that is the whole idea of percentages. Just writing a fraction out of 100, or dividing a quantity into 100 parts and then taking a fraction of it. Therefore, the symbol for percentage is the sign here. That's the symbol. And hence, if I write A with the sign attached to it, we say it is known as A%. That's the symbol. And therefore, it means that this A% can be expressed as A out of 100. A out of 100. So you realize that whenever you write any exams, either the teacher writes it at, okay, you are a very good student, so you had 95%. Or the teacher will go ahead and write it as, yes, what will it be?
95 out of 100.
95 out of 100. 95 out of 100. So, what is the meaning between these two numbers? This means that you've expressed this number from the percentage state to what we call the common fraction state. So you've changed it from the percentage state to a common fraction state. When we mean a common fraction, is simply a proper fraction. A fraction for which the numerator is always lesser than the denominator. That is what we classify as a proper fraction. And it is purely a common fraction. Please, are we all clear? So therefore, you can write percentages, or you can express common fraction from its state to a percentage state. So if I may ask, what do you think is a percentage for 25 out of 100?
25%.
That is simply 25%. How about 40 out of 100? What is the percentage of it?
40%.
That is 40%.
40%.
Thank you. So our next subtopic, after knowing what percentages are and then knowing why we need to study the concept of percentages, we are now moving on to the next, which is percentages as common fractions. Percentages as common fractions. So as I said early on, to write a percentage as a common fraction is just dividing the number by what? 100. Dividing the number by 100. So if I have 28%, that is going to give us a common fraction of what?
28 out of 100.
28 out of 100. In some cases, there's a need for you to reduce the common fraction into the simplest form. So if there is a need, you go ahead and do so. If not, you leave it as it is, depending on what they want you to attain. Then again, another example, I have 2.35%. What will be the common fraction for it? 2.35%. What will be the common fraction for it?
47. So
Can you take it again? Yes, 2.35%. What do you think it is? So one way or the other, what you need to have in mind is going to be 2.35 out of 100. And in this case, 2.35 out of 100, you can write it in the simplest form. How do we do so? This is the same as, please watch carefully, 235 over, or maybe when you go back to indices, you can write it as 235 times 10 raised to the power minus 2. Then all divided by 100. And this can go further to become 235 over 100 then times 100, which is 235 over 10000, 4 zeros. Then you can break it further and you end up getting 47 over 2000. One thing I want you to notice that percentages is not always going to be whole numbers all the time. Sometimes you may have decimals on board. So you should know how to manipulate your decimals. Please, are we all clear? Are we all clear?
Yes, please.
Yes.
If there is a question on what
Yes.
I've done over here, just ask and then let me go further to explain. Now, when you simplify 28 on 100, what are you going to obtain? When you simplify 28 out of 100, what will you obtain, please?
7 out of 25.
All right, 7 out of 25. Thank you. So basically, this is how you express percentages as common fractions. This is how you express percentages as common fractions. We'll be applying them very soon, so please take note. We are building on the concept from one point to the other. Because when we get to the application, some of these things are going to come back again. So please follow me as we go along. Okay, so I want you to try this for me. I want you to try this for me. Just about 3 questions and then you tell me the final answer. So convert the following percentages to fractions in its lowest step. convert the following percentages to fractions in its lowest term. So I have number 1 as 72%. I have number 2 as 0.5%. And I have number 3 as 80%. Convert the following percentages to fractions in their lowest term. 72%, 80%, and then 0.5%.
PDY,
Yes,
please, the number 2, what number is it?
0.5%.
Thank you.
Kiki. My God.
Hey.
Okay, so time is up. 72%. What is your fraction?
18/25.
Pardon?
18/25.
18 on 25. Any different answer apart from 18 on 25? 0. Okay, 0.5%. What's the answer?
1/200.
1 over
200.
200. Yes, any other answer apart from 1 on 200? Okay, no answer. Then 80%.
4/5.
4 out of 5. That is so good. I'm so happy you are all following this carefully. So when I get to the application side, I know I'm not going to have any problem at all. So we are done with the next one. The next we want to consider is the vice versa of what we just did. So whereas changing percentages to fractions, this time around we are going to look at changing common fractions to percentages. So changing common fractions to percentages. So common fractions to percentages. So whereas under changing percentages to fractions, we're dividing by 100, common fractions to percentages will be what? What do you think? Yes, common fractions to percentages. What do you think? It's just the vice versa of what we did the other time.
You multiplied fraction.
You just multiply by 100. So write it down, converting a common fraction to percentage, you just have to multiply by 100. Converting a fraction to percentages, you multiply it by 100. Converting a fraction to percentages, you multiply by 100. So for instance, you had 1 on 200 as a common fraction, 1 out of 200 as a common fraction. If I want to change this 1 on 200 to percentages, I just multiply by 100. And that is going to give me these 2 zeros does away with the 2 zeros there, and it's left with half. And half is the same as what? 0.5.
0.5.
You see how easy it is?
Yes, please.
Everything needs to be understood perfectly. Trust me. If you understand it, it's going to be easy for you to enjoy the whole topic percentages. It is not only applied in core math, it is also applied in elective math. So understand these bases very well. Please take note. All right, so converting a common fraction to percentages, we've established the concept that you multiply by 100. So let's take some work examples. One is 2 on 5. Number 2 is 7 on 50. And then number 3 is 3 on 5. No, let me make it 3 on 4. Let's change these numbers to percentages. So we multiply 2 on 5 by 100, 7 on 50 by 100, and then 3 on 4 also by 100. 5 will go into 100 how many times? Pardon?
20.
20. So 2 times 20, we are going to have 40 with a percentage attached to it. Meaning that when you convert 40% to fraction, you should end up getting the answer as 2 on 5. Good. Simplify 7 on 50 by 100 for me. What's the final answer?
14%.
14%. Then 3 on 4 by 100. What's the answer?
75%.
75%.
Thank you.
Hey, Simon.
75%. That is very good. I'm so happy you are following carefully.
Yes, please.
Let's go further. Let's go further. Let's go further. Now we move on to what we call decimal fractions to percentages. Yes, we are going to limit ourselves to decimal fractions. Decimal fractions to percentages. So looking at we are looking at decimal fractions to percentages. Decimal fractions to percentages. Therefore, if I have an expression given as 0.475 and I'm requested to write it as a percentage, how do I have to go about it? Remember, we learned that whenever you have any fraction and then you want to convert it to percentages, you simply need to do what? You simply need to do what, please?
Multiply by 100.
Multiply by 100. So if you have any decimal fraction of this nature and you are requested to write it as a percentage, you just need to multiply by 100. That is all. So 0.475 in percentages is going to give us an answer of 47.5%. I know most of you will actually write this using the calculator, the answer using the calculator. You are always stick to the calculator. But another way you could have also answered the question is if I have 0.475 and I want to convert it to a percentage, just multiplying by 100 without using the calculator, this can be written as 475 over 1000. I hope we are all clear with this. Then that will be multiplied by 100. 2 zeros will do away with 2 zeros here. So we are going to be left with 475 on 10. And 475 on 10 is the same as 47.5%. That is how manually you can answer the question. But the whole mark is that whenever you have any decimal fraction and you want to convert it to percentages, you multiply by 100. Please, are we all clear? Are we all clear, please?
Yes, please.
All right. So try this for me. Try this for me. Write the following decimals as percentages. So we have number 1 as 0.625, number 2 as 0.09, and number 3 as 0.72. Express the following decimals as percentages. You have less than 1 minute. Okay, so time is up. Number 1, what is the answer in percentages?
62.5%.
So 62.5%. Let me use a different color for student. There's number 2,
9%.
9%. It will be so sad that you write an exam and you just obtain 9%. Number 3, 72%. That's all. So based on what we've learned right now, we are just going to combine them. We've looked at percentages expressed in so many forms, some as decimals, others as common fractions, others in percentages actually. Now we are going to combine them. That's our next subtopic. And our subtopic is arranging numbers in order of magnitude. That's our next subtopic. So arranging numbers in order of magnitude. Now, when we are asked to arrange numbers in order of magnitude, when we consider the idea order of magnitude, we are looking at what we call ascending and descending orders. Ascending and descending orders. Ascending orders simply refers to writing the number from the smallest to the largest. And then descending order simply is the reverse of ascending order, which is writing from the largest to the smallest. Are you with me?
Yes, we are.
Again, ascending order is writing it from the smallest to the largest, whilst descending order is from the largest to the smallest. But interestingly, the numbers are not going to be as simple as class 1 things, such as maybe if I have the number 3, 4, and then 5, arrange it in descending order, then you give me the answer as 5, 4, and 3. No, it will never be like that. It's going to be in a form whereby it will be so much difficult to think of how to even do it. There is going to be the tendency that there will be fractions, common fractions, decimal fractions, and in most cases, percentages as well. How then do you go about it? The best way in doing such things is for you to write them in a form you can easily compare. In a form you can easily compare. And when I talk about comparison, since we've learned about percentages, then it means you can change all of them to a percentage order. Then you can just compare and write your final answer. So let's take first example. Arrange in descending order. So we have the numbers as 54%, 5 on 4, 0.52.
Sir,
And yes,
please, I don't see anything.
who else cannot see the screen?
Sir, please, me
Me.
too.
Me.
Me
Eva.
too.
Can you see the screen now?
Yes,
Yes.
please.
Thank you.
Yes.
Yes.
Okay,
Yes.
sorry for the interruption.
Yeah.
I don't know what exactly made the screen to go off. So as I said,
Or
I just got I've gone back one piece. As I said, we are looking at arranging numbers in order of magnitude. We talk about ascending order and descending orders. What we mean by saying ascending order is to arrange the numbers from the smallest value to the largest value. And what we mean by saying descending order is to write the numbers from the largest value to the smallest value. So ascending goes with an arrow of moving upwards, meaning from the tip of the arrow, go upwards, the large. And then descending order, just move from the smallest, from the largest to the smallest. That's how the whole idea is. So I just gave one example that we want to look at. And I advise that whenever you are requested to write any set of numbers in any of the orders, just express it in a form you can easily compare and then give your final verdict. And as I said, you are not going to have it so simple that you can just close your eye, open it, and tell me the answers. But you need to use a process to get your values. So the first example we are looking at is arrange in descending order 54%, 5 on 4%, 5 on 4, which is a fraction, 0.52, and then 3 on 5. These are the numbers we want to write them in descending order. Please, can you guess the largest which is in there? The largest number which is in here. Can you guess it? Can anyone guess it, please? And
54%.
54% is what you think will be the largest. Okay, you might be right, you might be wrong. We can't tell. But maybe you've used a process to get the answers faster. And if you are right, that's a very good way of getting your fast answers. So in order to be sure of which one is the largest and which one is the smallest, as I said, either you change them to a common form which you can easily compare. And we've just learned about percentages. So let us use the idea of percentages to work things through. 54% is already in percentages, so we don't need to do anything to it. But let us pick this common fraction, which is 5 on 4. We have to convert 5 on 4 to percentages. So what did we say converting fractions, common fraction to percentages, the process is? What must you do?
Multiply by 100.
Multiply by 100. So when you do so, 5 on 4 by 100, what answer are we getting?
One hundred and twenty-five.
Pardon?
125.
125.
125%.
25%.
Good. Let us pick the next one, which is 0.52.
52%.
So that is also multiplied by 100. It gives us 52%. And then finally, 3 out of 5 multiplied by 100. What are we getting?
3%.
62%. 60%.
60%. So you realize that now that we've written all these numbers in a common form, which is percentages, we can easily compare to know which one is the largest percentage. So you realize from the beginning, I asked, can you guess which of the numbers here is having the highest percentage? And one person told me that it's 54%. I said, you might be right or you might be wrong. And Unfortunately for her, her answer is not right. So please let us have a process to get our answers right. Yes?
This was the last fraction.
The last
3 over
fraction is
5.
3 on 5.
And the answer,
And the answer is 60%.
Nine.
Okay, so in this case, we've seen that the largest percentage among the data is 125%. And that should be followed by, yes, which one?
60.
60%. Then followed by
54.
54%.
54%. And then finally
53%.
52%. But you should bear with me that the question given to us was not in percentages, or these were not the numbers that was given in the question. So all that we need to do is to just write the actual values representing the percentages that we've given here. So in descending order, our answer must be 125% is being represented as 5 on 4. Then you can use the greater than sign, or you can use a comma. It's still accepted. Followed by 60%, which is represented as 3 on 5. And then finally, we have 54%, which was actually what was given to us in the question. And then the last but not least, as at 0.52. Please, are we all clear?
yes.
Yes, please.
So please take note. You must always convert the numbers given to you into a common form which you can easily compare to know which one is large and which one is small. And your final answers must be written in terms of the original question. Any question before I bring the next example?
Sir,
Yes, please.
is it always that you have to change it to percentage? Can you like maybe change all of them into fractions?
Okay, that's a good question.
Go, Hiki.
Now, it is not always mandated that you write it in percentages. You can actually write them also in fractions before writing the final answer. But I believe that percentages makes it very easy, and that is what we are talking about today. That's why I limited myself to percentages. I know that percentages makes it so much easy. Very, very easy. Because if you want to write it in fractions, then it means you are going to write a 54 out of 100 before you reduce it to the smallest unit. Likewise, 52 on 100, then you reduce it to the smallest unit. Then now watch something here. You see, I'm just trying to make the thing easy for you. If you convert 54 out of 100, then you need to write it in the smallest unit. The smallest unit will be what? Yes, just give it to me in the, pardon?
In decimal, it's going to be 0.54.
Okay, so decimals is another form of writing it. You can write it also in decimal fractions, and it's also equally good. But she was talking about fractions. So if you write this in fraction, it's going to make the work more complicated. But if you write it in decimal fraction, then you should know how to compare your decimal fraction. That's one thing you should be careful with. In decimal fraction, you are going to have it as 0.54. Then your 5 on 4 in decimal fraction, you obtain it as 1 point what?
1.25.
1.25. Already we have our 0.52 still being 0.52. Then finally 3 on 5, what are we going to obtain?
0.6.
0.6. So you should know how, this is another way of doing it. That is using the idea of decimal fractions. That's another way you can do it. So you realize that they are all written to what? Two decimal places. Two decimal places. And we also have a whole number section. So obviously having 5 on 4, which is having 1.25, that makes it the largest because the rest are having 0 as their unit, but we have this as 1. So 1 is greater than 0. That's one way you can compare. So we have the 1.25 being the largest among the decimal fractions here. Then we come to the next. Coming to the next, since this is out, we are no more going to use it. We are now going to compare 0.54 and compare 0.52 and then compare 0.6. 0.54, 0.52, they are the same. Like the fives are the same. So it means you cannot use that. Then you have to come to 0.6. So 0.6 will be the next value, which is larger. Then now coming to 0.5, 0.5, the next unit for 0.5 is 4 here and 2 there. So it means 0.454 will be the next, and then finally 0.52 will be the next. So just look at the process that we are going through from this using the concept of decimal fractions. Whereas that one, if you don't know how to compare your decimal fractions very well, it's going to be very difficult. But with percentages, you know that one value is larger than the other straight ahead, for it to make it easy for you to get your answer. So please, you are not limited to what method to use, but trust me, it is always best to use the simplest method and something that you can easily understand. Please, am I clear?
Yes, please.
All right.
Yes.
So I want you to try this for me within 1 minute. Within 1 minute, I want you to try this for me. Arrange the following numbers in ascending order. So arrange the following numbers in ascending order. I have my numbers as 0.72, followed by 87%, followed by 7 on 10. Within 1 minute, you should finish it. The last number is 7 on 10. Let me write it well. 15 seconds gone.
Sir,
Yes, please.
sir, please, the ascending order. Okay, so the first one will be 7/10. Then 0.72.
7, 2.
Then 87%.
Very good. Any other answer? Any other answer? Okay. Next one. So that is right. So as I said, just change all of them to percentages and it will be easier for you to do that. For those of us who are not able to do it, this is how you should have gone about it. 72 or 0.72 times 100, which is actually going to give us 72. Then 87 is already in percentages, so we just maintain it as it is, 87%. And then finally, 7 on 10 times 100. 10 goes into 110, so giving us 70%. So getting this done, it means the smallest value is 70, which was given to us in the question as 7 on 10. And then the next that follows is 72%, which was given in the question as 0.72. And lastly, 87% follows up. Please, are we all clear?
Yes.
All right. The last example over there. The last example over there. Are we ready? Within 1 minute. Within 1 minute. So let me set my.
Sir,
Yes, please.
please, my screen is still on. Write the following decimals as percentages.
Your screen is writing the following decimals as percentages.
Yes.
Please, who else is also still at that same place? I guess you need to
Sir.
refresh your page, please. Kindly refresh your page. I beg you. Sometimes it's the network that causes that. So please, when you have a problem of that nature, just refresh your page. Please, are we all okay for us to continue?
Yes, sir.
Okay. So, as I said, my next question comes as this. Arrange the following, this time around, in descending order. So, we have the numbers as 0.9, 7 on 10, and then 85%. Express this in descending order of magnitude within 1 minute. Time starts.
Sir,
Yes.
please, I'm done.
Wow, that's
Sir,
great.
please, I'm done.
That's very good and sharp. Okay, so give me your answers.
0.9.
So
Oh.
0.9 greater than which number?
85%.
85%.
85%.
And then
And
obviously 7
7
on
over
10.
10.
Good. 7 on 10.
Wow.
Um, the student who said that the screen was frozen, please, are you with us now?
No, I'll subscribe it, but
Oh,
Okay, can you log out and log in again? We have less than 15 minutes to go so that you can benefit from the final section. Even though the videos will be there for you to also go over. Can you log out and log in again? Perhaps you can go along with us, please. Okay, so we are moving on to our last section. Our last section, and that is relative error and then percentage error. That's our last section for today. We are looking at relative error and percentage error. Now, the word error means what to you?
Sir, mistake.
A mistake. Straight ahead. All right. By mathematics, how would you express the concept of error? Yes, mathematically. how would you express the concept of error, please? I believe you say mistakenly writing something wrongly, right? Or you don't agree with that?
Say,
Yes.
what about when you punch numbers or words that don't make sense in the calculator? The results you get.
That's syntax error. So calculating something or programming a wrongful information can also bring on board an error. Yes. So when we consider the concept of error, it has so many meanings, but it depends on from which perspective you are looking at. So when we look at relative error, the word relative is always used or only used when it comes to measurement. When it comes to measurement, that's when we use the word relative. So you are supposed to measure a quantity and record some values, but you wrongfully wrote those information. Just imagine you wrote an exams. Yes, you wrote an exam and the teacher marked it and then wrote 69% instead of the turning number will be what? What will be the turning number of this? 96.
96.
This is the mark you should have obtained, but wrongfully you were given this mark. This is a huge error, right?
Yes.
Good. So in this case, we say that there is a relative error here. Sometimes the carpenters, they also make some measurements like mistakes. Or our seamstress and tailors, they make mistakes in our body measurements and so on and so forth. So when we use the word relative error is mostly used when it comes to measurements. And it simply refers to the comparison or ratio of the absolute value error to the actual value. So when we consider relative error, it is simply the ratio between the absolute value or absolute error divided by the actual value. That's the meaning of relative error. Are you with me?
Yes, please.
Now, someone may ask, what is the meaning of absolute value or absolute error? Now, absolute error is simply the difference. This is a symbol for absolute sign. It's just 2 bars. So difference between the two numbers. That is what we classify as the absolute error. We put it in between an absolute sign. So for instance, the teacher was supposed to give you 96 and he gave you 69. To get the absolute error, it is either absolute value of 69 minus 96, for which you are going to get what value? Absolute value of negative what?
Negative 27.
Negative 27.
Mm?
For which absolute value of negative 27 is positive 27. Whenever you find the absolute value of a negative number, it simply changes it to a positive number. The meaning of absolute simply refers to taking the number from zero. Taking the number from the 0 point. So the same person could have calculated the absolute error as 96 minus 69. And that would be giving us absolute value of 27. And the final answer is still going to give us 27. So when we consider the concept of absolute error, it doesn't always refer to whether it is the largest number minus the smallest number or the smallest number minus the largest number. All that you need to do is to put it in the absolute sign. And the absolute sign will just change any negative number you obtain to a positive number. Please, am I clear?
Yes, please.
Are we all okay with what we classify as absolute error?
Yes.
No.
If you have any question, please you may ask before I move on.
Please, that's the absolute sign.
Oh, it's just a bar. So it's like 2 bars. 2 bars. Then you write the expression in it. So if I have absolute value of A, that's how it is written. Yes, please.
Please, what's that? The difference between the two?
Numbers.
Oh, okay.
2 numbers. So
Yeah.
this is it. If I have absolute value of 3, the answer is 3. Absolute value of -3, the answer is still what? 3.
Sir,
Yes,
so an absolute value of something, it can't be negative.
it
It always
can.
has to be positive.
It is always supposed to be positive.
Okay.
Yes, because it simply refers to taking the number from or the distance from 0. Taking the distance from 0. It's
Yes,
like
please.
on the number line. What's something here? On the number line. If I have 0 here and I have 3, I have -3. If I ask you what's the distance from 0 to 3, what will be the answer? The distance from 0 to 3. You know that the distance, a distance sign is this. I don't know if you've seen it before. Sometimes length is classified as line AB or the distance of AB. Do you remember this? The sign over there
Yes.
means distance. Have you ever seen a negative distance before?
No.
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 Yes.
No.
So that braces over there, the square
No.
braces is simply referring to absolute value. Absolute value. So when it comes to relative error is simply the absolute error divided by the actual value. Absolute error divided by the actual value. And when we talk about absolute error, it is simply the difference between the two numbers placed in between the absolute sign. So irrespective of how you wrote it, if you had a negative number, it will change to what? Positive. Please, am I clear?
Yes, please.
All right.
Okay.
So determining the relative error, it is simply the absolute error over the actual value, as I said. So if they ask me to determine the relative error for the teacher writing 69% instead of 96%, is simply going to be the relative error. Let me just cut it short as RE. The relative error is going to be the absolute error, which is going to be 69 minus 96 all on 96, because 96 was the actual value he should have written, but he ended up writing 69. And hence, this is going to give me 27 on 96. If there is a need for you to break it down, you do so. I believe 3 can go into 27 and 3 can go into 96. So that is going to give us a final answer as 9 on 32. Is it 32? Yeah,
Yes, please. It is.
9 on 32.
Yes, please.
Please, are we all okay?
Yes, please.
And
Please have
yes, I'm listening.
and please, what's the difference between relative error and absolute error?
Relative error and absolute error. Relative error simply is a fraction of absolute error and then actual value. And absolute error is simply the difference between the two values that makes the error.
Okay, so if you have to find a relative error, that means your answer has to be in a fraction.
Exactly.
Then an absolute error, your answer has to
Be a single number.
be a single number.
Yes, a whole number. Then the final thing is percentage error. Interestingly, if you don't know your relative error, you can never get your percentage error. If you don't know your relative error, you can never get your percentage error. So when we consider percentage error, percentage error is given as, watch, the absolute error over actual value times 100. Remember, we said that percentage is just converting a fraction to 100, right? Multiplying by 100. So in other words, absolute error over actual value, what does this expression give us? What
Okay.
does this expression give us?
Relative error times 100.
Exactly. That's why I said that if you don't know your relative error, you can never get your percentage error. Please, are we all clear?
Yes, please.
All right. So in some books, the actual value can also be given as original value. Actual value can also be given as original value. Actual value can also be given as original value. So note, I don't want you to learn these things as formulas, but I want you to understand the process. Because when you quote any formula, we don't give you any mark. But when you do substitution rightly, that's when the marks are awarded. All right, let's take some example before we just call it a day. Let's take an example before we call it a day. So this is the question I have here.
PDY.
Yes,
Please, you said actual value is the same as.
original value.
Thank you.
So I have an example here. Number one is find the percentage error in approximating
Mhm.
approximating 2.7 as 3. Find the percentage error in approximating 2.7 as 3. That's number one. Number two is find the percentage error in approximating 4.5 as 6. 4.5 as 6. This will help you to appreciate that it is not always wise to approximate numbers because it brings a lot of confusion. Don't ever try it. So even when it comes to mathematics, whenever you want to approximate any number, we always say that leave it to a maximum of 4 decimal places. So if you are very interested in science and math quiz, you realize that their final answers, they always leave it to 4 decimal places or at least 3 decimal places. They don't leave it to 1 decimal place or a whole number. No, because it causes a lot of confusion. So find the percentage error in approximating 2.7 as 3 and also 4.5 as 6. Just tell us the percentage error. This time around, I'll give you 2 minutes to finish it up. You have 1 minute, 5 seconds to go. Twenty seconds. And the time is up. Okay, so can you share your answers with me? Let me write it in a green color. Question number 1. What was your percentage error?
10%.
Pardon?
I have 10%.
You had 10%. Please, did I hear it rightly as 10%?
Yeah.
Yes, any other answer apart from 10%? Okay, number 2. What was the percentage error?
25%.
25%.
25%. Okay, let's find out whether these are the right answers. So in other words, getting the percentage error, question number 1. We need to determine the relative error, which is giving us the absolute error divided by the actual value. Now the question is, which of them is the actual value? This is where you should be very careful. It says find the percentage error in approximating the number what? 2.7 as 3. So between 2.7 and 3, which one do you think is the actual value that should have been written? Or which one is the original number, if I may ask? You approximated 2.7 as 3. Which one is the original number?
2.7.
The original number is 2.7. So in other words, getting our percentage error is going to be absolute value of 2.7 minus 3, all divided by 2.7, then times 100. And absolute value of 2.7 minus 3, when you subtract 2.7 from 3 or the other way around, the answer is going to be 0.3. I hope I'm clear.
Yes.
You are not clear. Why are you not sure of? Let me know. Is it the original number or actual value that you are confused? Yes, which one? Is it the original number that we said to be 2.7, or which one are you not clear?
How to know which one is the absolute error?
Oh, how to know which one is the absolute error? As I said, absolute error is the difference between the two numbers you are comparing. But when you subtract the smaller from the largest or the largest from the smaller, just put it in between an absolute sign, whereby it is going to change any negative number to a positive number. That is all. Please, are we okay? So if you should have said that maybe the original number is what you are not sure of, or the actual value that you are not sure of. Now just listen to the statement. Find the percentage error in approximating 2.7 as 3. So instead of you writing 2.7, you said that I'm too lazy to write two numbers, so I'm going to write it as 3. Therefore, 2.7 is the actual value or the original value, but you chose to write it as 3. And that's where the 2.7 is our original value. Please, are we okay?
Yes.
Are we okay? So that I can finish up.
Yes, please.
All right. So this will be divided by 2.7, then multiplied by 100. Final answer from your calculator. What do you have?
11.11111.
So we have 11.111%. So it means the error is so great. It is more than 10%. You have approximated more than 10% of the actual value, which is very bad. That is number 1. Number 2 follows the same pattern. Let me use a yellow marker to write the number 2 process. So number 2 process, our percentage error will be equal to, yes, what do we have? What do we have? The
You have to find the absolute value, which
yes, the
is
absolute value of 4.5 minus 6, all divided by, what is the actual value among the two numbers?
4.5.
4.5. Then all multiplied by what? 100. So 4.5, yes, please.
Please, when you are solving it, can you change the 4.5 to 4.5?
Yes, you can choose to write it as 4.5. The reason why I'm still maintaining it as 4.5 is for the fact that sometimes your decimals might not be terminating decimals. Yes.
Okay.
So that's why I'm still maintaining it in the fraction state. So please, let's be careful. If not, you are going to approximate and approximate and approximate again. So sometimes it's best to write it in the fraction form.
Yes, sir.
All right. So 4.5 minus 6 will give us negative 1.5. But because the absolute value sign is there, then it means we are going to have 1.5 over, or one whole number 1 over 2 over 4.5
It's raining.
times 100. Final answer is what, please?
33.333.
So 33.33%. 33.33%. 33.33%. Yes, this is just the beginning for core math lesson in percentages. And in our next lesson, we are going to move further. But I would like you to go over the video when you have the chance and then just review some of the things we've done, because in our next lesson, we are going to add more to it. Now, then again, as I said, I have this YouTube channel and the name is Math Made Easy with PDY. When you go to YouTube, I have lots of videos there. You can actually review some of your math lessons and then some WASI work examples. I'll be very privileged to get you subscribing to the channel, giving comments, and then liking some of the videos that I have there. If you have some topics you want me to put there for revision's sake, kindly inbox me and then I'll do that for you so that you can also review lessons on those topics. Thank you so much for joining the lesson. We shall meet tomorrow for elective mathematics, and the topic we'll be considering is trigonometry. Thank you and have a blessed day. Bye-bye.
Bye.
Bye.
Bye.